Okay, I'll give a solution to problem 5. All right, so remember, what is our recursive set look like? So it starts with, the initial case starts with a single vertex, right? Then applying the recursive rule once, we 2 copies, and we go like that. I guess you could think the V there, and then you have V. Those are the old V's, so we knock those out, got a V there. All right, then the next time, a recursive rule twice, we have something like this. Then we create a new V connected to the old. Applying the recursive rule, again, we have 2 copies of that thing. Create a new vertex, go like that, right? So recursive rule once, recursive rule twice, recursive rule 3 times. Yes, I can count. Okay. Okay, so you would notice, you notice that all those were trees, right? So that's the idea. We're going to prove that. We're going to prove by structural induction that X is a tree. Okay, so there's actually a couple things that we'll need for this. This is from the 14.1 worksheet. From the 14.1 worksheet. Okay, the first thing is that a single vertex is a tree. A single vertex is connected, is trivially connected, meaning that between any 2 vertices, there's a path. Well, there's only one vertex, so that's true. And it contains no cycles. Okay, so a single vertex is a tree, and that's really that's the base case. All right, so another, from 14.1 worksheet, if you have a tree, whatever that tree looks like, and it doesn't have to be one of these special binary trees that are in this problem. Could just be any trees, or just. Okay, so when you add a new edge, so if you review the 14.1 worksheet, you'll see that we talked about this when we worked on that worksheet. That is that if you create a new edge between any 2 vertices of a tree, between a vertex of one tree to a vertex of another tree, you create a new edge, you get a tree. Okay, and that's really what we're going to use. So from the 14.1 worksheet, what do we got there? Let's see, adding a new edge between, adding a new edge between an existing vertex in one tree and an existing vertex in another tree creates a tree. Okay, so right, the idea here is here we had some tree, here we had some tree. We added a new edge, the red edge there, between an existing vertex and one tree to an existing vertex and another tree. And then when we do that, we get a tree. Okay. All right, so base case. Remember that the base case, we want to prove the property we're trying to prove, that X is a tree for the initial case. Okay, so here we're trying to prove that a single vertex is a tree. Okay, we already know that's true. So by 14.1 worksheet, a single vertex is a tree. Okay, inductive step. Inductive step. Okay, so we have, assume X is in S and P of X. And P of X is true, that X is a tree. So assume that X in S is a tree. Okay, and we're going to show that Y, which is created by applying the recursive rule, let's say assume Y was created by applying recursive rule to X. Okay, so what does Y look like, right? We had some X in S, right? And our recursive rule says create two copies, one right next to the other. Create a new vertex, call it V, connect that to the roots of the old, right? This is Y. That's Y. Okay. All right, so you see how this is working, right? This X is a tree and X is a tree. And so here we're connecting, all right. And we'll look at it like this, okay? Think about how the recursive rule works, right? We have X, we take a copy, we make another copy of X right there. And then we connect this new vertex V, right? Remember, this is a tree. So V is a tree, right? A single vertex is a tree. And we connect it with an edge right there. When you draw an edge from one tree to another tree, you get a tree, right? And so this will be a tree, and then applying that same concept again, we draw an edge from one tree to another, and we get a tree. All right, so we're just going to explain that. The single vertex of Y is a tree. So the graph formed by drawing the edge from V to the left copy of X is a tree. This is by 14.1 worksheet. Similarly, the graph formed by drawing the edge from V to the right copy. Oops. Is a tree. That's it.